Hi all, welcome to part 3 of the video lecture on relational data model. See, here we will be seeing something called as relational model constraints. So similar thing we already saw in ER model also. There we observed the ER model constraints. Now this relational model constraints are also says something similar to that, but it is somewhat more detailed, because this relational model or the representation, it's a representation or implementation model, right? It is more close to the implementation. So at this point you have to specify constraints in a more detailed manner. Okay. So in the previous two parts of the video lecture, we covered the basics of a relational model in an informal as well as formal way. Okay, so that about it. Now, so if you are looking at constraints in a relational model, basically you can classify it like some of them as inherent model based constraints, right? So that is one thing. Then schema based constraint, right? And application based constraints, or semantic constraint, or business rules, like that. So three categories you can think of. So by default, when you define a relation, the former meaning, right? It's the subset of the Cartesian product of the domains and ordered n tuple. So that kind of things are the default definition of the relation itself conveying them, right? And also, within a set, elements are not supposed to repeat, so that within a relation the tuples are not supposed to repeat. So something like that. So all these things are inherent model based constraints. So whenever you are defining a relational model, whether it is relational model or some other implementational model, inherently it is holding some set of constraints. So they are also called as the implicit constraints. Okay, so they are there by default. Implicitly we have these constraints. Now the constraints that can be directly expressed in the schemas of the data model, typically by specifying them in the DDL. So through data definition language, if you specify the constraints as part of defining the schema, we can call them as a schema based constraints or the explicit constraint. Explicitly you are specifying them. Okay, and when you are defining the schema, some hint you will be giving. I mean, this there is some way of defining this constraint explicitly along with the schema. So the definition of the schema says these are all the constraints that are there. Okay, so it's not inherently held by the database, so it's not implicit or inherent, so they are known to be the explicit constraints. So by along with the definition of the schema, these constraints are also expressed to the database. Okay, now the third category, the constraint that cannot be directly expressed even, right, in the schemas of the definition of the data model, and hence must be expressed and enforced by the application programs or in some other way. So when you define the schema, you are not able to explicitly mention them, and at the same time they are not implicitly there in the database. So such constraints are also there. So that is coming from the user or the application program. So when you are defining the program, there is this backend you will define using some DDL. You will define the structure, everything, and that time along with this along with this structure, you will define this explicit constraint. Now this application based constraints are something which you can't specify along with the schema, or it's not implicitly there in the database. So as part of the application program, you will mention them specifically. So when you start that programming, you will see them in detail. But anyway, at this point we are going to discuss the middle category, that is schema based constraint or explicit constraint. That we will focus more, because the implicit is something by default they are holding. In the last category, along with the you have to mention them through the application program. Okay, so that is something different anyways. So and there are something additional also. So minimum you should have a knowledge about the schema based constraint or explicit constraints. That is what we are going to see in detail. And another important category of constraint is something called as data dependency. This also we will study in detail when we maybe in the further modules, right? So which include the functional dependency and multi-value dependency. Don't worry about functional dependency or multi-value dependency at this point. We will see them in detail when we discuss the normalization concept. Okay, and these are used for testing the goodness of the design of the relation database, and are used in a process called normalization. See, this normalization, these dependencies, everything we will see in detail when we are discussing that. Okay, so in our future videos. Now see, in this video lecture we will focus mainly on this schema based constraint. So more about it. Inherent constraints are something which are inherently there in the data model, right? For example, the relation cannot have a duplicate tuples because the definition of the relation itself says that it is set. In a set, elements are not supposed to repeat, right? It's a basic set definition, okay? So like that. The second category, namely those imposed by the data definition language, the schema-based constraints, is what we discussed right now. Okay, so this is what we are going to see now. The constraints, the third category, are more general and they relate to the meaning as well as the behavior of the attributes and are difficult to express and enforce within the data model. So they are actually checked within the application program that perform the database update, and that we may see in future. Okay, so in some cases these constraints are also called also specified as assertions. So using assertions we can specify such a application or semantic based constraints. Okay, so the schema based constraints is what we are going to discuss in detail. You can expect them in your university exam also. Explain different constraints on relational model. If they are asking like that, you can explain the schema based constraint because they are the main constraints. Okay, so we will see each of them in detail. Starting with the domain constraint, then key constraint, constraints on nulls, entity integrity constraint, referential integrity constraint. So these 5 categories. So out of them, some are very important and some you just have to know, something you already know also. Okay, right. Then domain constraint. Domain constraint means, as the name says, every attribute is having a domain, right? Hope you remember. Every attribute is having a domain, and from that domain the values are supposed to come. Then only we can call a state as valid. Otherwise, it is an invalid state if it is taking some value outside the domain. So that only is what this domain constraint. So when you are defining the schema, define this domain very clearly in such a way that if a value is coming outside the domain, you can say that it's an invalid state. So if you want more accuracy in the database, you define your domain accordingly. So that is one. So this is something that come along with the schema definition. Only that schema definition can ensure this, right? So what is needed by the user, that should be correctly mentioned in the schema as the domain. So the domain should be described correctly. So that is what. So you are not supposed to violate the domain. So this is what the domain constraint says. Domain constraints specify that within each tuple, row, the value of each attribute A must be atomic value. So this is something we already seen, like in a basic relational model or flat relational model, or from that first normal form assumption. In the previous video I discussed this. The relation is supposed to have only atomic value. Multi-valued or composite values are not allowed, and it should come from the domain. So this also you know, but now we are giving it a name, that this is what is the domain constraint. So when you define the domain clearly, you are ensuring this constraint. The data type associated with the domains typically include standard numeric. So it can be integers or real numbers. Okay. Now it can be characters, booleans, fixed length string, variable length strings, date, time, timestamp, etc. The domains can also be it can be some enumerated kind of thing or sub-range kind of thing. Anyway, when we discuss that SQL, we will see more formal way of defining domain and all. Okay. Anyway, some domain is there and you are not supposed to violate the domain. So that is what the domain constraint says. So if you are violating, you will not get a valid state of the database. That's all. So by default, it will be ensured by any relational database management system software. Now another one is something called as uniqueness constraints. This also we saw in ER model, the same thing only. So there should be some attribute with respect to which one attribute or set of attributes with respect to which you should be able to differentiate each and every tuples in a relation. Okay, so if you take any two tuple, suppose I have n attributes. In worst case, all the n-1 attributes may be same, but at least one attribute should be different in such a way that we can differentiate these two tuples. Okay, so basically this is something inherently also this is this meaning is there, like we can interpret it as an implicit constraint also. But when it comes to a schema based constraint, what we are trying to say, in the schema itself you should provide a means for achieving it. Okay, implicitly, you know, relation is a set of attributes. Within a set, elements are not supposed to repeat, so that is there. Now how we are achieving it, that is by mentioning some of the attribute as a key attribute. So what is a key attribute? for which the values are not supposed to repeat. Okay, so we can enforce that. So when you have a definition of a database or I mean as a relation, some of the attribute, one or two minimally, should be mentioned as a key attribute by which you can achieve this uniqueness constraint. Okay, so now it goes along with the schema, so that is why it's coming under schema based constraint. Okay, so what is the key that we will see? Formal definition. So right now you can understand that it is something for which the values are not supposed to repeat. So by definition, all the elements are should be distinct, right? So distinct in the sense at least one attribute should hold this. Then only we can achieve this. All tuples in a relation are distinct. This means that no two tuples can have the same combination of value for all the attribute. Okay, if it is repeating same value for all the attribute, then only I can say that it is having duplicates. We don't want it, right? So hence there must be a subset of attributes. Subset in the sense it can be a single attribute or more than one. What is minimum needed? Okay, of attribute in schema for which the values are not going to repeat, right? So with the property that no two tuples in any relation state small r of capital R should have the same combination of value for this subset of attributes. So this subset is what we call as a key. Particularly we use the term something called as superkey. Okay, so what is a superkey? Superkey in the sense, when I am saying it in a more general way, it is superkey. So I am just saying that it is a subset, but I am not giving any constraint like it should be minimal subset or something. So this is a general terminology, right? So the only requirement is I need a collection of attribute from the relation, or a subset of attribute from the relation. Subset in the sense, in worst case it can be all attributes of the relation also. So that also a subset, right? So it's a very general definition, right? We don't want it. We need a more specific definition. We will see that. Anyway, superkey definition says that I just need a subset of attribute. In worst case, it can be all attributes of the relation even. Okay, so that is what is denoted by SK. And now take any two tuple T1 and T2. T1 and T2 are two random tuples you are taking from the relation. So the subset of attribute SK, together you take the value, they will be different. Okay. Suppose that we denote one such subset of attribute by SK, then for any two distinct tuples T1 and T2 in a relation state small r of capital R, we have the constraint that for the tuple T1, if you look at all values for this SK, and T2 if you look at all the values for the same SK, they should be different. Okay. It may be because of one attribute inside it or all attribute together, that we don't know. Anyway, we are just defining it as a subset, that's all. A superkey specifies the uniqueness constraint. So with the help of this superkey, you can achieve uniqueness constraint, and that no two tuples have the same set of values, right? So every relation has at least one default superkey for sure. So what is that? The set of all its attributes. Because subset, I just need a subset of attribute for which the values are different, right? So the whole attributes together, if you take, that will be different, maybe because of one attribute. So what I am trying to say is, suppose in a student table, let the attributes be student roll number, then name of the student, some grade, okay, and some other information, address, etc. Now you can see that if you are looking at names, two students can have the same name, right? Possibilities are there. You can't say that when you take admission, a particular student is not supposed to have a name of another student. That you can't impose, right? That is meaningless. So two students definitely. So this field can repeat, right? For two tuples, this field can be same. And also, even though they are having same name, if they have a different grade, that is fine. But we can't impose like that. Worst case, so it may happen that two students with the same name is having same grade. Some other information like age and all we are storing, they may also repeat, right? But that is the speciality of this roll number. What I can impose is two students in a class are not supposed to have the same roll number. Now this roll number is something that acts as a unique identifier for the student. Okay, so but I am looking at students of a particular classroom. But if you are looking at students of the college as a whole, two different classes may have students with the same roll number. Okay. So now what I can do is I can generalize it. So right now you assume that I am talking about students of a single class, right? Now can you tell me some superkeys of it? I just need a subset of attributes of this one. So this is having many attributes, say age, etc. Many are there. So just focus these three. Can you think of some subsets which are superkeys? Like so if I am taking roll number alone, it's a super key, it's not going to repeat, right? So if I'm taking roll number and name, now together also it is not repeating, but actually it is because of roll number, that we know. But still, if you take these two values together, it is not going to repeat. Similarly, roll number, name and grade, right, and grade, this is also not going to repeat, right? So like that you can think of any combination, any subsets of the attributes of the given relation, and you can call it as a super key. So all these are super keys. So this is super key 1 and this is super key 2 and this is super key 3, like that. You can think of anything. Now if I am taking a subset like say name, okay, so let me add a grade also. Can I say that it is a super key? No, it's not a super key, right? Why it is not a super key? Because I can have two students with the same name and grade, of course, but it is not possible to have two students with the same roll number or same roll number and name together, like that, right? So all these are super keys. Now what we are interested is something, this one. So what is speciality of this? This is something called as a key. So key in the sense, it is a minimal super key. So right, so what is a key? So key is a minimal super key. Minimal super key in the sense, so it's very important. You can think of any subset as a super key. Super key is a more general definition. Now what we are interested in, we don't want such a bigger subset. What we are interested in is some smaller subset which is having this property. Okay, so it can be a single attribute or it can be something more than one attribute also. I'm just trying to have an example for the sake of explanation. Let me tell about the same student table. Now what I'm thinking is, I'm not focusing on students of a single class. So if that is the case, roll number will be unique. Now it can be students of all departments of your college or something. Okay, so in that case, you know, two batch students may have same roll number. So what I'm doing is, I'm keeping this roll number, and at the same time I'm giving some class code also, right, in which class he belongs to, like second year, third year. Maybe this class code I may be formulating by using the department and maybe semester, and using some other information I am making this class code. Okay, now let me keep the remaining information like name, grade, age, etc. So what I can see is these things can repeat, but this roll number if I am taking, so it is something like this. Suppose a student is having a roll number 5, so he is from so class code you have to give in a very wise manner, so that is my assumption. So suppose he is from the CS department and he is in semester 1. So maybe semester 1 we have a different batches also, right? So let me call that he is from batch 1. So like that I'll be giving. Now you can think of so he is having some name, grade, those things are there. Okay, so you don't worry about these things. Now what I'm thinking is another student, say from the same class, like a CS S1 batch 1. So what I guarantee I'm having is, within a class this roll number is going to be unique. That is something we already know, right? So you are also in your class there is no two students with the same roll number, right? So if I'm looking at another student, definitely his roll number will be some value other than this 5. So let it be some 7. It can be anything, some randomly I'm taking. Now what it can happen is, I can think of another branch, say mechanical engineering department. Say there I am looking at some first semester or any semester, there say semester 3, say batch 1, something like that. So this is another class code. So what you can see here is, here I can have a student with a roll number 5. So that is fine. But if I am looking at this same thing, you are not supposed to have this student with the roll number 5. It can be something different. Okay, so what I'm trying to say is, so if you look at the values like this, you can see that this roll number, if you are focusing alone, it is repeating, right? This roll number is repeating. This 5 is getting repeated here and here. Okay, now if you are looking at this class code alone, that is also repeating. So the class code as an attribute is not having the key property. It is not, I mean, it is not having that uniqueness property. It is repeating. Roll number is also not having that uniqueness properties. But when you take this class number and roll number together, it is not repeating. Okay, so together it is unique. Hope you get the meaning. So what I can say is, I can just think of different subsets of the given student table. So let me tell you, let me ask you whether it is a key or not. So my question is, if I am taking roll number and name, is it a key? Now, or super key, simply first you think about super key, then you can think about the key. Okay, now if I am taking this roll number alone, is it a super key? Now if I am taking something like a class code and name, say, and grade, is it a super key? I just need a subset of attributes which are unique. Okay, now another combination I can think of is this roll number, class code also I am taking, and then I am taking name also. Now another combination I can think of is roll number is there, class code is there. Okay, fine, that's enough. Okay, like that you can think of any subset, and then you can keep asking whether it is a super key or a key. So now you can see that it is not a super key, right? It is not a super key because you see two students can have the same name and same roll number, because it can happen like how it can happen. Two students are having same number and roll number and same name. In the sense, students are having same roll number means they are on different classes. Okay, so they can also like that 5 and 5. So these two students, so their roll number and same, but coincidentally their name may also be same. So suppose his name is X, he can also have the same like a grade, everything may be same. So we can't ensure that. Okay, so it's not going to be a super key. So if it is not a super key, it is not a key also, right? So first of all, super key means it should be a super key minimum. Okay, then roll number if you are taking alone, definitely it is not a super key. Okay, so it is not a key also, fine, because it is repeating, right? Then class code and name, same situation, class code is repeating, so okay, it is not a key. Any superset of it is also not a super key. So if it is not a super key, then you don't have to think about a key. Okay, so first of all it should be super key, then if it is minimal you can call it as a key. Now what about this roll number, class code? So they together is unique, that we know, and when you add this name also there is no issue. So it is a super key, but you know it is not a key. It is not a key, fine, because it is not minimal. Now when you are looking at this, so this is important, this is a super key and at the same time this is a key. Why it is so? Because it is minimal also. So why it is a key? Because it is minimal. Okay, let me use that term. So it is minimal. It is a minimal super key. Minimal super key is what we call as a key. So hope you got a feel of it, what it is, or you can think of some other example also. So what I am trying to say is it can be a set of attributes, subset of attribute which is unique. So that is a definition of super key. But when it is minimal also, I can call it as a key. Minimal in the sense, so what do you mean by minimal? When you remove one of the attribute from this, that key property should be violated. Like if you remove this class code, roll number alone is not a key. If you remove this roll number, this class code alone is not a key, but together it is a key. Okay, but at the same time here it is not a key, because if you remove name, still it is a key. I mean, still it is a super key. Such things I don't want, right? So this, here I can say that this name is actually a redundant thing, right? So this is redundant with respect to so this is redundant. So let me use that term, redundant, in the sense with respect to that uniqueness, right? So without this also I have that uniqueness property. So to have that uniqueness property, this name is actually redundant for me. So they are like superfluous, right? So remove all such redundancy and keep the super key minimal. At the same time, the key property, I mean uniqueness property should be there, right? So then only I can call it as a key. Fine, hope you get it. So every relation has at least one default super key, that is set of all attributes of the relation. Now when it comes to super key, so the super key can have a redundant attribute. For example, here this name is a redundant attribute, and so here also this name, grade, these things are redundant. So remove them. Okay, so it can be finally a single attribute or it can be a subset of attribute, but it is minimal. That is the thing. So what we need is, however, we have a more useful concept called a key, which has no redundancy. So what makes a key different from a super key is it's having no redundancy. Redundancy in the sense, such attributes are redundant, you can remove them, still it is having that key property. For maintaining that uniqueness property, this is something redundant. So that is the meaning we are having. So what is a key? Key of a relation schema R is a super key, capital R, with the additional property that removing any attribute. So how can you, so here when you remove this name, still it is a key. We don't want it. Removing any attribute, you remove any attribute from this set of attribute key, and you will get a subset, that is k dash. It is no longer a super key, then only I can call the original one as a key. So hope you get it right. So once you remove some of the attribute from the key, it should lose that uniqueness property. Okay, so otherwise it is not a key, it will be a super key. So what we can say as a formal definition, so this is very important, try to understand the meaning in the right sense. So what is a key? First of all, it should hold two property. First, key is something that holds a uniqueness property, and also it is a minimal super key. What is unique property? This is something common for key and super key, right? So it should together it should be unique. Okay, so two distinct tuples in any state of the relation cannot have identical value for all attributes of these two. I mean these subset of attribute in super key. Now it is minimal super key in the sense the super key which we cannot remove any attribute and still it is having the uniqueness constraint hold, right? So once you remove one of the attribute, like that key property should be violated, the uniqueness property should be violated. Here it is a key because when you once you remove this class code, roll number alone is not at all a super key or a key. Fine. When you remove this roll number, again class code is not having that uniqueness property, but together it is having this uniqueness property, and it is minimal also. There is no redundant element like a name. Okay, so that is what is a key. So uniqueness property should be there and it should be minimal. Okay, so what we can see is a key is a super key but not vice versa. So if you are looking at this, this is a key as well as a super key, but here it is not a key. But it is a super key, right? So I can't say that all super keys are key. Minimum super keys are only keys. So all keys are super keys. Fine. So a super key may be a key, but may not be. Super key may be a key or may not be a key. We don't know. If it is minimal, it is a key. Fine. Same thing, different interpretations. That's all. So example of a key attribute. So here instead of that roll number, they are taking something called as SSN, that's a social security number, some unique identifier. So as it's a foreign author, they are using something like this. So just like roll number or KTUID that you are having, here it is some unique ID, right? That's all. So if you are looking at this whole subset, it is a super key because of this SSN, as it is unique, SSN name, age together is unique. But you know, if you are looking at this SSN alone, it is a key because you don't need the support of. So here this SSN alone is fine, just like that roll number within a class. But if you are looking at the college as a whole, class number and class code together is acting as a key. Sometimes it can be like that also. So by default, a key with the multiple attributes must require that all its attributes together have that unique property, just like example we saw before. See, in general, super key is formed from a single attribute. So by default, I have a super key with a single attribute. Super key with a single attribute, it will be a key because super key, it is a super key, but it is having a single attribute. Definitely it is minimal, right? It is a key. Fine. Otherwise, you have to see once you remove some of the attribute whether it is having the creep property, uniqueness property or not. Similarly, we cannot designate the name attribute as key in the sense it can repeat, right? For two students, same name can be there. Now, in a given relation or table, if we have more than one super keys, okay. I mean, now super key topic is over. Now we are focusing only on keys, okay? So if we have more, so minimal super key is what we are interested now onwards. That is the key. Super key is just a definition, okay? You have to know what it is, but in a meaningful way, we are interested only on the minimal super key, that is key. So that itself we can divide as the, you can call sometimes as a candidate key, primary key or a unique key. So the thing is that in a given relational table or a relation, you can have more than one key attribute in the sense, for example, if you are looking at that car relation, right? You know, for a car we have this license number which is unique, right? For different cars we have a unique license number, and at the same time this engine serial number, that is also unique. So license number alone is a key, and with other field you can think of the model, the price of the car, color of the car, like that any attribute you can think of, and out of them other things can repeat. But if you are looking at this license number alone, it is a key. Engine serial number is a key. It is not a composite key, they are independently two different keys. Okay, fine. Now you can make a if that is the case, in when you are creating any relation, if you are getting more than one keys, you can call them all as a candidate key. So because all are candidates, right? Because this license number is a candidate key, engine serial number is also a candidate key. It is candidate in the sense we don't know whether we are going to fix it as a key, I mean as the primary key, right? So in a given relation, it is enough to have a single candidate key as a primary key. So within a table, if you have more than one keys, we can call them as a candidate keys, and out of them the designer of the database will choose one of the candidate key as a primary key, right? Designate one of the candidate key as a primary key and make all other keys just alternate keys or unique keys, right? Just to ensure that all other attributes are having that uniqueness property, so that you can specify in a different way, and one of them you call as the primary key. So that about it. So it is up to your choice which is convenient for you, whether you want to make license number or engine serial number as a primary key. That is something from the mini vault. So you can ask the end user who is using it, and accordingly you can fix one of them as the primary key and make the remaining ones as a just unique. Okay, unique in the sense they are not going to repeat, but they are not the primary key. Okay, fine. So it is common to designate one of the candidate key as a primary key of the relation. This is the candidate key. See, so here I use like a candidate key, I'm writing like a CK, primary key like a PK, like that. Okay, super key is something I written like SK. Okay, so this is a candidate key whose values are used to identify tuples. So by default, from the implementation point of view, this is something that makes the tuples unique. Okay, so this is the main attribute which is holding that uniqueness constraint. So we are not worrying about others. Okay, so we have some special attention to primary key when it comes to implementation. We will see that, and primary key itself we impose further constraints you will not allow this primary key to be null, and we will see this later. For example, if you are allowing that primary key to be null, means that key attribute can two people having null means we are not able to distinguish the tuples, right? Because null that is something two people can have the same name, address and all other things, and this primary key is also null means, so those two tuples are similar now, so we don't want it, right? So for primary key we have the restriction that it should not be null, but other keys like unique keys you can allow null also. So that is special case. So like that some special attention we will give this for this primary key attribute. Anyway, so we use the convention that the attributes that form the primary key of a relation schema are underlined, but typically in the relational model, when you write it, when you draw it, this key attribute should be the primary key attribute should be underlined. Okay, not key attribute, primary key should be underlined. Yeah, now notice that when a relation schema has several candidate keys, the choice of one of them become the primary key is somewhat arbitrary only. However, it is usually better to choose the primary key with a single attribute or a small number of attributes. So that is something convenient for us, right? So if a particular primary key is having some single value, so by default is single valued only, but yes, one attribute, or if it is not possible, one or two, like make it minimum. In the sense, I have one candidate key with one attribute and another candidate with two attributes. So I will be choosing that one attribute candidate key as a primary key. Sometimes I have one of the candidate key say with the two attribute, and another candidate key is having three attribute. Then the one with the two attribute I will be choosing as a primary key. Okay, like that. Now the other candidate keys we designate as unique keys. We also call them as alternative keys, right? So keys, but they don't have any attention like primary keys. It should not be null. Those constraints are not applicable for them. So here you can see this car license number we designated as the primary key. So that is what we underlined here. So this is a primary key here. This is a primary key here, but this is just a key, right? A candidate key, which is not a primary key. We call it as unique key. Okay, so something we can designate it as a unique attribute. And these are all normal attributes, that's all. So here in the employee table, you can see this SSN is the primary key because it is underlined, other are not. Similarly, here this D number is the primary key. Here in department location is another table we are maintaining, where this department number and location together is the primary key. So what is the primary key here? Here you can see that the primary key is a set like having this department number and department location. Because see, you can have a same department in different location, right? So if you are looking at department number L on say it is in Mumbai and Hyderabad, so department number is say 100, so 100 Mumbai, 100 Hyderabad, so it is repeating, right? So I'm just randomly picking some values like So why they are together acting as the key, I'm trying to explain. So department number, I'm giving department number say 100 for a department, and the location be some Mumbai, and another the same department is even located in Hyderabad also. Now I have another department, say 101, that is also located in Hyderabad. Now what you can see, this Hyderabad, if you are looking at this location alone, if it is repeating, and this is also repeating, but together department number and this department location together, it is not repeating. So together it is acting as a primary key. And similarly here in project, this is project number can be the primary key, and works on relation. This particular employee is working on this particular project on this many hours, okay, and we will see why this relation this ER model to relational model mapping, we will see after this. Okay, anyway, here these two together act as a primary key. That also you can see, employee number can repeat, project number can also repeat, but together it's not going to repeat. Similarly here in dependent table, the employee he is dependent on which employee, so that information also we are keeping here. Now dependent name, hope you remember it was a partial key in ER modeling. Right now this dependent name and ESSN together is going to act as a primary key for this dependent table. Okay, anyway, now you can assume that these are all the primary key, and how we are getting it we will see later. Okay, now one more constraint I just want to tell you is not null constraint. If you want, you can impose some of the attributes they are not going to allow any null. So that is another constraint that we can specify along with the schema definition. All these things we discussed so far, we are schema based constraint, in the sense when you define the schema you have to mention them also, right? Then only okay, so that we will see. So when we define the schema formally using SQL, and that time I will show you how to give these constraints also, not null. We just write when you define an attribute, we will say attribute name, attribute type, then we will write not null also, saying that this is acting as the this particular attribute is not supposed to have any null value. So whenever the user try to insert any null value, it will show a not null constraint violation error. Okay, so that will be guaranteed by the database table. So that is the next constraint, that is you can specify whether null values are allowed or not. So for example, student table, you can say that this name of the student should not be, because student means there should be a meaningful name for him, right? So you are not going to allow null value for this name. Like that you can give this constraint. So all this you have to mention along with the schema definition, primary key, everything you will mention along with the schema definition. And whenever you try to violate this any of this constraint, when you insert the data, it will be thrown as an error by the DBMS software. We will see them formally when we discuss that SQL. Okay, yeah, thanks for watching. And I think two more constraints are there. They are more important, like that, like a foreign key referential integrity constraint and all, and we will see them in the next video lecture. Yeah, thanks for watching.